Hello everybody, and welcome to the lemma on page 55 of the workbook. And in this lemma, we're just going to explore some of the general properties of cosets. Some of these properties we've already observed in the examples that we've done. Okay, so there are a lot of statements in this lemma. We're gonna just talk through a couple of them, see if we can make sense out of them. Let's start by reading the statement of the lemma. So let H be a subgroup of G, and let A and B just be two elements in our group. A lot of these statements that we talk about are going to have to do with the cosets generated by A and B. Okay, so I want to just try to pick the elements on the list that I think are the most important here. You can read the rest of these on your own. Let's start maybe with statement number 2. It tells us that the coset A times H is going to be equal to H itself, the subgroup, exactly when A is an element of the subgroup. If you look back at the examples we did, you might notice this behavior. It happened. Okay, there were nice illustrations of this in the first few examples that we did. Okay, and then probably the most important one on this list is number 3. Okay, it tells us that when we talk about cosets, there are exactly two possibilities. Okay, either you're going to discover that the two cosets AH and BH are exactly identical, or they're completely disjoint. Okay, it's telling us that we can't have partial overlap of cosets. They're always going to either be identical or completely different. Okay, this is the behavior that guarantees us that the cosets will always partition our group. Okay, I'm going to write that out in words. Okay, this indicates that the cosets partition the group G. Okay, and moving on to statement 4 here, this gives us a way to check to see if two cosets are going to be equal to each other. This is convenient sometimes if you just want to know if two cosets are equal without having to write out all of the elements in your cosets. It tells us that AH and BH are going to be the same coset when this condition is satisfied, if A inverse times B is an element of H, the subgroup. Okay, and the last one I want to mention specifically is 5. Okay, remember what those bars mean? They're just talking about the order of the set, okay, the number of elements in the set. So it's telling us basically that if you look at any two cosets, they might be different, but they're always going to contain the same number of elements. Okay, so I'm going to write that out in words too. Same number of elements in every coset. Okay, so we can't have two cosets that have different sizes. They're all going to have the same size. Okay, now to conclude this video, I'd like to do just a brief illustration of one of these. Okay, I'm going to pick on number 4 just so we can kind of see that in action. All right, so we'll call this an illustration of number 4. Okay, and we'll refer back to example 3 at the top of this page. Okay, so I'm going to scroll up here a little bit. And notice that in example 3 up here, one observation that we made was that the cosets 6 times the subgroup generated by 2 and 5 times the subgroup generated by 2 were the same thing. And remember the group we were working in there, it was U7. Okay, let's see how that relates to statement 4 here. All right, so I'm going to write the observation that we made in example 3. Okay, so 5 times the subgroup generated by 2 is 6 times the subgroup generated by 2. And in the context of this lemma, that's true because if you took A inverse B, remember the A and the B in this case are the 5 and the 6, because 5 inverse times 6, let's do that calculation. What's the inverse of 5 in U7? Okay, well, 5 inverse is actually equal to 3. You can check that because if you take 3 times 5, you get 15. That's equal to 1 mod 7, okay, the identity element. So this is 3 times 6. And 18 mod 7 happens to be 4, and notice that that 4 lives in the set H, 1, 2, 4. Okay, so we've just exactly confirmed statement 4 here. Okay, AH and BH, the A and the B again were the 5 and the 6, those are equal precisely because of the fact that A inverse B wound up being an element that's in our set H. Okay, let's check that for one more case just to illustrate that that works. Okay, so two other cosets that were equal were these two. Okay, 2 times the subgroup generated by 2 and 4 times the subgroup generated by 2. Okay, and that's true according to this lemma because of the fact that if we take 4 inverse times 2, 4 inverse is equal to 2, okay, because 2 times 4 is 8, which is 1 mod 7. Do that multiplication and you get 4, and once again, that's in H. That's our criterion according to this lemma that tells us that the two cosets are equal. Okay, that concludes this video.